Okay. The technique that our discussion last night that most of you liked for solving an equation with fractions. Okay, or in more fancy talk, solving rational equations. Rational means fractional equations. You guys like the technique where first you get a common denominator on all the fractions, and second, you drop that common denominator. That was the method you guys said you liked. So to get a common denominator, I need to make them all the same. So this has an x plus 4. So does this, but it doesn't have an x minus 4. So I would multiply this problem by x minus 4, top and bottom. Okay. This has an x minus 4, but it doesn't have an x plus 4. So I would multiply this by x plus 4, top and bottom. And if I do that, I end up with 2x squared minus 8x over x plus 4 times x minus 4 minus, this is going to be 8x plus 32. 8 times x, it distributes 8 times 4 over x minus 4, x plus 4 equals 2x squared plus 32 over x minus 4, x plus 4. So like I said, that's the technique you guys said you kind of liked, or a few of you said that. Get a common denominator for everybody. So any hesitation to that point? Any questions you want to ask about that?
Yes, it's not on the 8x plus 4. It's not negative 8 minus 32.
Not yet. I haven't distributed yet, but it will be in a second. You're a step ahead of me, or a step or two ahead of me. Okay, I wanted to talk about that. Okay, she's asking, do we distribute the negative here to make this negative 8x minus 32? I'll do that in a minute. Okay. So is everybody okay with getting a common denominator? And now we're going to drop the common denominator. And this is where it comes from me. This is 2x squared minus 8x minus all of this, okay, equals 2x squared plus 32. So I'm reminding myself that I need to go minus this entire quantity, minus all of that. So that's going to become 2x squared minus 8x minus another 8x minus 32 equals 2x squared plus 32. Holy crud. All right, questions on my work so far?
So do we want to make the whole thing 0, or do we want to do all common?
Well, that's kind of a decision you have to make. In the end, it won't matter. But I would look at this and I'd go, oh, it's got a power, exponent. So I want to make it equal 0. But watch what happens when I take 2x squared. I can go one step down. I'm just looking to see what's on the screen. But what happens when I take 2x squared away from this side and take 2x squared away from this side?
Cancels out.
They cancel out. So all of a sudden, it looked like it was going to be a power equation. It looked like I had to make it equal 0. I started to, but all of a sudden, the power dropped out. So now I have negative 16x, I'll get out of the way, minus 32 equals 32. So negative 8x minus 8x, that's how I got negative 16x, minus 32 equals 32. So that's how I got that equation up there. Okay. So your question was really good. Yes, you saw the power, you knew make it equal 0, but all of a sudden the power drops out. So you go, what do I do now? All right.
So
This is just- go ahead.
nothing. You're good.
You sure?
Thank you.
Yeah. All right. So this is now just a plain old ordinary linear equation, chapter 2 stuff, get x alone. So we're going to add 32 to both sides. And we're going to get negative 16x equals 64. Okay. Then we're going to divide both sides by negative 16. Okay. Use your calculator. In my head, which is much better today than it was last night, I get negative 4. You guys agree?
Yes.
Okay. Any questions about my work to that point? X equals negative 4. Any questions at all about any of my steps, any of my work? What happened to the denominator? Anything? Okay, problem is negative 4 is wrong.
Should be positive, right?
Nope,
No.
nope. I've made no mistakes to this point. It's just wrong.
If we are
Why
gonna
wrong?
put it in denominator instead of x, it's gonna be 0.
Bingo. Remember, okay, we need to check for restrictions. Okay. If you take negative 4 and put it into one of the denominators, any denominator, will it make it 0?
Yeah,
Yes.
Yeah, right there, it'll cause that denominator to become 0.
undefined.
Okay, so we reject this, reject. But we've rejected our only possible answer. So because of that, okay, we have no solution
Hmm.
to this problem. We did all this work, and the only answer is there is no answer, no solution. Okay. Again, for test or quiz, if you got to here and you said negative 4 is my answer, okay, the worst you would lose is 1 point for not rejecting it, for not checking it rejected. Now, wait a minute. I'm not telling you that every answer is going to reject, but I am telling you that some answers might reject, so you have to think about it. But the worst it's going to cost you is 1 point.
Out of how many points?
This would be about a 5-point problem.
Okay, not bad. Hey,
Yeah.
what about the surveys? You're still collecting those, correct?
I'm going to collect those tomorrow night. There's
Okay.
no way to collect them tonight.
Right,
So,
right.
yeah.
Well, I was
Yeah.
actually gonna ask, how many are you said you're gonna give us some points for that as well?
Yeah. For those
You
of
know
you
how-
who turn it in tomorrow night, yes.
How many points? do you get for
I
that?
don't know.
50 or
Not
so?
many. Huh?
50 or so? No.
Oh, no, not
Just
that many.
kidding, just
Good.
kidding.
Keep trying. Okay. Keep trying though, you know, you'll
Yeah.
get there sooner or later.
Hey, swing for the stars.
Yeah, why not?
I do have a question for this problem.
I'm sorry.
I do have a question for this last problem we worked on.
Okay. Go ahead, shoot.
So you subtracted the 2x squared and then you made it equal to 32. Could have you subtracted the whole thing, 2x
Yeah.
squared plus 32?
But then eventually you got to get this. Remember the game was get X on one side, numbers on the other.
Yeah.
Eventually you're going to get this answer. Maybe it took you 3 steps and took me 2. Who cares? You okay?
Yeah.
Okay.
And then last for the 2x squared minus 8x minus in parentheses 8x plus 32. How'd you turn that into the negative again?
Because the negative sign really represents a -1.
It factored into it, right?
And I just multiplied the -1 into that.
Okay.
Yes. Okay. Good discussions. I like this. Okay. Let's see if I can cause, while I erase the board. If this blows up on me, I will log back in as quickly as I can. No, that's not what I want to do. Stop. Okay. That's what I want to do. Okay. Take a second to write that down while I erase the board. Everybody got it written? Can I switch back to my, no? Okay. Okay, I do want to get going on it, so I'll put it back up later if you need it. I'm going to switch back. Computer. Whee. Right. So this is a proportional word problem. Okay. Yesterday we talked about similar triangles and how their corresponding sides form a proportion. Remember, a proportion is one fraction equaling one fraction. Well, this is a word problem, okay? And it sets up as a proportion, but you can't draw pictures for this problem. But what we can do is it says it takes 0.5 cc's of whatever this drug is for each 12 pounds of body weight. So that gives us a comparison, 0.5 over 12, where the top of this, okay, represents the drug, and the bottom of this represents the body weight. Okay. The question then says, okay, if a child weighs 83 pounds, well, we set that equal to something else, but the question is, and this is where my tongue started not working last night because I couldn't say it right, where do I put the 83? Where do I put the 83 pounds?
At the bottom with the weight.
Good, 83. And so X, okay, represents what? When I put it in this proportion, what does X represent?
See
The
if you-
dosage.
The what?
Want to do your dosage?
The dosage, how much of the drug I'm going to use. So to make it simpler, is 0.5 over 12 equals X over 83. And as long as you're comparing similar on similar, when we said 0.5 over 12, we're saying drug goes on top, weight goes on bottom. So when we make it equal, that's got to represent the drug dosage on top, that's got to represent the weight. Did anybody multiply it out and get an answer?
3.45.
I'm sorry,
3.45.
3.5.
what did it say it around to? 10th.
There's 10th.
Okay, 3.45. Okay, round to the nearest 10th is going to be 3.5 cc's of whatever it was, meds, which is still a lot. Okay, again, remember when we have a proportion, all we have to do is cross multiply 12 times X, 0.5 times 83. You guys need to see that step, or are you okay?
Yeah, can I see that?
Yeah,
Okay.
same.
Okay. Then I'll come back out here. 0.5 over 12 equals X over 83. When we have a proportion, okay, which is one fraction equaling one fraction, we can do what's called cross, not cancel, but multiply. Okay, so that means we can multiply this times this. 12 times X is 12X. And we can also multiply this times this, 0.5 times 83. And the rest of this work is done on your calculator. So you knock in 0.5 times 83 and you get 41.5. So we have 12X equals 41.5. Then our algebra says divide both sides by 12. Divide by 12. And my calculator says X is 3.4.4583333. But the directions in the problem said round to the nearest 10th. So this 4 is in the 10th place. So we look here, is the 5 big enough to kick the 4 up? Yep, the rule says 5 or greater. So we get the 3.5 is our answer for the number of cc's. Okay. So again, word problems, similar triangles, okay. Comparing different weights or different quantities in proportion sets up just easy proportions. You cross multiply, it's pretty easy. I believe, I forget what section that was in, Mom. 8.7. They're all pretty much either similar triangles or something like this. And I'm not real big on them. I'm going to put one of these on the exam, not on the quiz, on the exam. So don't lose too much sleep, but keep working on it. All right, now I want to get into what I really bungled last night. Okay. Okay, we started last night. I am recording. Okay. Chapter 8, Intermediate. Which was titled Roots and Radicals. Okay, and I said they should have included exponents. Okay, one of the key idea here is some vocabulary. When we write a root like that, okay, this number out here is called the index. The number inside, 5, is called the radicand. And the whole symbol itself is called the radical. Radical. So when we say this, we talk about this is the third root of 5, or we talk about radical 3 over 5, or something like that. We use, in different instances, different words. So if I'm using a phrase that you're uncomfortable with or unfamiliar with, stop me, make me explain myself, because we have different vocabulary that means the same thing. Okay. So sometimes I'll call this the cube root. Sometimes I'll call this the third root. Sometimes I'll say, hey, this is the radical with index 3. And they all mean the same thing. If you're unclear about what I just said or what I need to do, make sure I clarify for you. All right, a couple things before we get into the juicy stuff. When we do this, most of us have learned that this is the square root of 4. Okay, why? Well, because for a square root, the index is always assumed to be a 2, like square power. You know how you write x squared, we call it that? Well, when the power is 2, we use the word square. When the index is 2, we also use the word square, but we put the word root on it. So this is the square root of 4. Okay. Whenever we leave the index off, it's always assumed to be a 2, always. If we leave the index off of a problem, it's the square root of it. Okay. If we mean the cube root or the 4th root or the 5th root or some weird root, okay, then we have to put it in there. Okay. Now, there's a couple of super duper important rules. Rule key number 1, okay, and this is the key to almost everything in this chapter, is I give it to you as the nth root of x to the nth power is always x. I mean, Okay, in the point of honesty, okay, it's not always X. There's a little subtlety there about 0.1% of the time, but I'm not going to worry about that one right yet. Okay, so the nth root and the nth power always cancel each other. Okay, so for example, if you had the cube root of 5 to the cube power, the cube root, index of 3, cube power, it becomes 5. Bam, just like that. Okay, if you have the 4th root, now I'm being weird here, for watch, of 3 to the 4th power. Look where I wrote my power. I didn't write it on the 3, I wrote it on the overall thing. But it doesn't matter because the power of 4 and the index of 4 always cancel each other out. Always. So this becomes 3. Okay. So this is a very, very, very important rule. It's what allows us to simplify our radicals, to make them prettier, to make them more normal. Okay, I would like to erase these 2 examples here about the cube root and the 4th root. Does anybody have any questions before I erase these 2 examples?
So does the odd and even rule apply to this stuff as well?
That's going to apply a little bit, yes, but
Okay.
I'm kicking myself. After class last night, I sat there and I reviewed everything I did, and I'm going, God, some of that, it's important to know, but it wasn't important to know at that time. So I was very angry at myself because I chose a really poor way to teach it. We'll come back to odd and even, but not now.
Okay, so just kind of disregard all that. Just focus on this.
I'm glad you have it in your mind, and that'll make it easier when we bring it back. But yeah, just disregard it for now.
Okay, thank you.
Yeah. Can I erase this cube root 4th root stuff for everybody else? All right, no one's yelling at me. Okay. Now, the next key number 2, is if you have the nth root of a number, A, and you multiply it with the nth root of another number, B, okay? These can be combined into the nth root of A times B. Now, a couple things. This symbol here, this double arrow-headed symbol, is a symbol that mathematicians use to mean a rule is bidirectional. Okay, this says if you've got 2 numbers multiplying together inside of a radical, you can shove them into the same radical. But it also implies that if they're already in the same radical, you can take them apart if you want to. Okay, it gives you that option. So this rule is bidirectional. So example, suppose you have the cube root of 5 times the cube root of, let's say 10. According to this rule, you can shove them together as the cube root of 5, or I'm just going to say 50, because that's what 5 times 10 is. Yes or no?
Yes, but the index has to be the same.
Has to be the same. That's why nth root, they got to be the same. If they were different, it's beyond our pay grade right now to deal with it. You can deal with it. It's a pain in the rear. Okay, so what about the 4th root of 2xy to the 3rd times the 4th root of 6 x to the third, y to the second.
Would that be 12 x 4 y to the fifth?
Okay, so 12, the fourth root of 12 x to the 4, y to the 5. So the rule says you can multiply these, put them together and multiply them. Then it's up to you to decide, well, how do I do that? Well, multiply 2 times 6, that's easy. But now this is my exponent rules. So you have to decide. The rule just says you multiply them. You, as a student, get to decide how you're supposed to multiply them. Okay. Now, some of you who have an experience in here, these answers are not complete, but I don't want to bog us down yet. All right, I want to put up one more rule. Can I erase my cube root and my fourth root?
I have one question.
Sure.
So could you make the last thing you did where it's the index is 4 and then you have
So
you
the
make
fourth
that-
root,
could you make that a fourth root of x, y times the fourth root of 6 x to the second, y to the, you see what I'm saying?
no, I'm sorry.
Um,
You mean,
Could you rewrite it as the cube root of 4 to xy and then to multiply that by 12x x
no,
to the
you're just,
fourth.
all you're doing is saying, I'm going to put these two together as a big giant fourth root, and I'm going to go 2xy to the third times 6x to the third y squared.
Okay,
That's all we're doing. We're just taking this mess multiplied with this mess and using our rules for exponents, coming up with that answer.
okay, so I was just wondering if it can go in the reverse, like if you want to
Sure.
between
Sure. Now, so what,
X-
if I hear you right, okay,
1 and 12.
or 3 and 4, is that where you were getting the 4 from?
Yeah, well, no, I was trying to say it, but I'm super tired, so. brain's not really
Well,
working.
wait, I used that excuse last night. I gotta come up with a new one, okay?
I haven't had my caffeine.
Okay. Yeah, you know what? Doctor took me off of caffeine. Said it causes kidney stones. I'm really angry. So what you're saying is, for everybody else, let's go with, suppose you started with, let's start with something simpler. 12x y squared. Let's go with something a little bit simpler. Okay. You're saying if I could take this and see it as 4 times 3 times x times y times y, could I take that apart as something like 4, the fourth root of 4y, those two, times the fourth root of 3xy, those. Is that what you're asking?
Pretty much.
Yeah. And the answer is yes, you can. In fact, that's going to be in a more controlled way. We're going to do that in just a little bit. Okay. All right. I need to erase these and put up one more rule for us tonight. Can I erase this cube root of 5 and this fourth root of whatever?
Yes.
Nobody's going to yell at me. Okay. Then,
Whoa. Just kidding.
no, yeah.
You gonna build some other
Yeah,
issues,
remember,
man.
I'm grading your paper, okay? You blew it. Yeah.
I have a good Trump joke.
No, after class, I'm supposed to keep politics totally out. Okay,
I'm just kidding. I mean,
because some people actually like him, but so we'll keep politics out until after class, or tell me tomorrow in person. That's even better.
Just not when we're recording.
Yeah,
yeah, I'm
that's
just
true.
kidding. I'm just joking.
No, that's okay. I appreciate them all, but we need to keep politics technically out of the classroom, especially a math classroom. I can't figure out how I can justify, oh, let's go a Trump joke or a Putin joke or something like. No, that doesn't fit in a math classroom yet. All right. Anyway, back to here. Key number 3. Okay. If you have the nth root of A divided by the nth root of B, then if you want, okay, you can put them together as the big giant nth root of A divided by B. And again, this rule is bidirectional. If you have a fraction inside your radical, you can take it apart. If you have two separate radicals that are dividing, you can put it into one big radical that's dividing. Okay. And I'm going to come back and do problems on this. But these are our 3 keys that we have to kind of know. What are we allowed to do when we see radicals? What are we allowed to do? These are our 3 main fundamental steps that we're allowed to do. And then, of course, tomorrow night, I'm going to give us more. And you guys are going to run away pulling hair out of your heads. Okay. I will show you examples of this 3rd rule later, but those are our big 3. Again, the double arrowhead means the rule is bidirectional. So sometimes we like it like this, sometimes we like it like this. And this gives you the ability to switch it from one form to the other. Okay. Can I erase all of this and start doing some real problems?
Yeah.
Okay, everybody got these rules all copied down? And I am recording. And by the way, I recorded last night's, and I put a big giant apology on the recording for how bad it was, but it's recorded and it's posted on Canvas also. It links you to YouTube, but it's there with all my fumblings and mumblings. Okay, so the first thing we started last night, we got all those rules, and I'm going to refer to them, is we talked about how to simplify a radical. So I just want to walk you through a problem. Let's take the cube root of 24 x to the 3rd, y to the 4th. Okay. I can't make you do it my way. I can tell you what you need to be thinking, okay, and why you need to think that. But many of you can do a lot of this in your head. Many of you need to break it down into little steps, okay? But let me show you what you need to do. You want to break up everything inside this into groups of 3. The index tells us groups of 3. So you look at 24, for example, and that turns out to be 2 to the 3rd times 3. How do I know that? Because I've done this for about 1 billion years, but 24 is 4 times 6. You start breaking it down, 2 times 2, 6 breaks down to 2 times 3. Okay, so this is called a factor tree. So you kind of on your scratch paper or something, go off and do a little factor tree, okay, on your number. Personally, when I see 24, I automatically think 8 times 3, because I know, because of doing this for a billion years, that 8 is 2 to the third power. That's how I do it. Okay, but my way comes from a lot of practice and experience. This is the way most students do it until they get the hang of it. They do a little factor tree, break it all down, and then find their groups of 3. So 24 becomes 2 to the third times 3. X to the third is x to the third. It's a group of 3 already. 3 times 3, x, 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 x. Y to the fourth can be broken up as y to the third times y to the first. So that's the first thing you need to think about. Whether or not you write it, that's your business. All right. Now, don't write this step yet. Don't write this step.
Why'd you split them?
Because I need to get them into groups of 3 powers.
Gotcha.
Okay. Okay. We're going to use that second rule to allow us to break this up Okay, now hang on. It's much easier than what I've written. Remember what the second rule was. If you had the cube root of a times b, you're allowed to break that up into the cube root of a times the cube root of b. So if you've got a whole bunch of things multiplying together, okay, you're allowed to break it up. Well, hang on, don't write this yet. Okay, just hang with me. Just watch what I'm doing. What is the cube root of 2 to the third power? What is that?
2.
2. Just automatically 2, because the cube root, the index, and the power cancel. Times, what is the cube root? Well, you can't do the cube root of 3. Forget it. We can't do that one yet. I'm sorry. I'm jumping ahead. What about here? The cube root of x to the third. What's it become?
X,
X. Okay. The cube root of y to the third.
Y,
Y. Okay. And we can't do anything with that. Okay. So what happens is students rarely show this step here that I showed. Instead, they say, oh, this 2 cubed will come out as a 2, come out of the radical. This x cubed will come out as an x. This y cubed will come out as a y, and these other things will simply stay inside. So our final answer for this problem is this. This is our simplified answer. Okay, let me go over that again. Technically, we're supposed to break it up into powers of 3, as many as we can. Technically, we're supposed to then separate it into a bunch of little baby cube roots. And we're supposed to simplify the ones we can simplify. But in reality, nobody does this. That's the technical way. And everybody goes, oh no, that's way too much work. So instead, what we do is after we get our groups of 3, we just say, who is going to come out of this mess? The 2 is going to come out because it's a power of 3. The x is going to come out. The y is going to come out. 2xy came outside. Who stayed inside? The 3 and the y. That's our final answer. All right, now I'll be quiet I told you not to write this. I'll be quiet if you want to write it. Okay, and I'll answer questions also. Okay. Any questions on my work here? Personally, I think most of us would do something like this and then jump to this. You could do that. It's quite easy. Let's try though another example. I want to do the fourth root of 32 x to the fifth y to the sixth z. So I want you to simplify that radical, the fourth root of 32 x to the fifth y to the sixth z. Oops. So there's my breakdown. I took 32, did a little work over here. Okay, well, I suppose I should erase that. Broke 32 down. It became 2 to the fourth times 2. X to the fifth, I split as x to the fourth times x. Y to the sixth, I split as y to the fourth times y squared. And z doesn't split, so it just hangs there. So who comes out? A 2, an x, and a y. So a 2, x, y come out. Who's left inside? A 2, this x, a y squared, and that z. And that is my final answer. Questions?
So I had started by 4 squared times 2. But the index has to be 4, huh?
Right.
Well,
So if it had been a square
okay. Gotcha.
root, if it had been a square root, then your start would have been good. But because it's a fourth root, that tells you you have to get fourth powers in there.
gotcha. Yeah, yeah, slip my mind.
Okay. Anybody else?
Okay, so the goal is to get the power inside to be 4. Or like whatever the index is. for the-
Whatever that's the goal there. And
That's
then
the goal,
once it
okay.
is that number, once they match, you can, because we're skipping rules, you can just say, okay, that's going to come out. Yes.
Okay.
Are you doing okay, everybody? Okay, let's do another one. Can I do it here? Yeah. Let's do this as an example. The square root of 18x to the 5th, y to the 4th, good enough. The square root of 18x to the 5th, y to the 4th. Hint, what's the index before you get started?
2.
Score.
2, square, whatever. Yeah, it's not there in the original problem. You have to know that it's implied to be a 2. So go ahead and work that. So this is what I have. 3 squared times 2, x squared, x, y squared, y squared. So I can take out a 3, 2 x's, because I can take that x out and that x out, and 2 y's. Okay, and what's left inside is a 2 and an x. So final answer, put it back together. I'm still on the screen. 3 x to the second, y to the second, square root of 2x. How are we doing? Want to do a few more of these before we move on?
Yes.
Yeah.
Yeah, okay. Okay, are we okay? I mean, are you okay with this answer here? My work in this answer? Anybody have any questions or hesitation on this problem that, because I need to start erasing the board.
So the x to the second power just did you just subconsciously just take that away? Because I understand the it goes against the integer.
You mean going from here to here?
Yeah, like because I see the 2 x's, because I know you're taking the x from the x to the second power, but
Yeah.
why does it become just x to the second power? Does it cancel out or?
Yes, yes,
Oh,
it
okay.
does.
All right.
Okay, remember, okay. Let's take an easier problem. Let's take 18. The square root of 18x to the third. Slightly easier problem. Okay, this is going to become 3 squared times 2, because that's 9 times 2 is 18. And this is going to become x squared times x. Okay, so that's if I do a factor tree and all that other junk I'm talking about. Are you okay going from this problem to this problem?
Yes.
Now, technically, what we do is we break this up as the square root of 3 squared times the square root of x squared times the square root of 2x.
Okay.
And the
Yep.
question is why? Because this is the square index and
Mhm.
the square power. So we just say they cancel each other and the 3 shows up outside.
Okay.
That's what happened here. This was a square root index and it canceled the square power there. So the X comes out. Then it does the same thing to the other X. It comes out also.
Gotcha.
Yes or no? I mean, I hope.
Yes.
Okay.
No, yeah, because so it's kind of like the imaginary one. like
Yes,
from
in a way,
before.
yes.
Yeah, because we're supposed to know it's a square root.
You're supposed to know,
2.
yeah, it's a square root, so there's an invisible 2 up there, yeah.
So it takes the
Or-
2, but because of like terms, it brings it back to x squared again.
You know,
Oh,
yeah,
for the
well,
other problem,
right
yeah.
here,
Yeah.
once you've pulled everybody out, now you look at that and go, God, that's a mess, can I make it easier?
Mhm.
And instead of saying X times X, we call that just X squared,
Okay. Yeah. Understood.
okay? All right. I like it, I like it. Any other questions before I do another problem for you? Or have you do another problem? Okay. Let's do. Okay, I want you to do 2 problems. One is going to be the cube root of 48 x to the 5th y to the 6th. That's problem number 1. Problem number 2 is going to be the 4th root of 48 x to the 5th y to the 6th. So one is a cube root, one is a 4th root. Try and simplify those. Okay. So I put both answers with minimum work up here. And I'll be happy to address your questions. This is a root. Little root, got tongue hanging out.
Okay, so starting on number 1, do
Yeah,
you have to, so I got the 16 cube, do you have to break it down to the
Yep.
2 like you did?
you have to take like 48. Okay, and because it said the cube root, you have to break it down until you have a lot of things to the 3rd power. So I use 6 times 8, break it down some more. 6 breaks down to 2 times 3. 8 breaks down to 2 times 4, but you break it some more. So you have 2 times 3 times 2, and the 4 breaks down to 2 times 2. So now what you do is you look at this and you put it back together as groups of 3. The index controls everything. It tells you how to group your problem. So first you do a factor tree on 48, break it down, then put it back together. I see 2 to the 3rd and 6. 6 times 2 to the 3rd there, and that's what I put there. Did that answer
I
your
get you.
question?
See, because I just put 16 to the 3rd, and I just left it like that.
Wait a minute. 16 to the 3rd is 16 times 16 times 16, which is a really big number.
Right. Okay, I see what happened. Yeah.
Okay. You were thinking 3rd power, you meant 16 times 3. That's 48. But we're doing
Yeah.
powers. We're doing powers.
Okay.
I got the answer, but I forgot to add the index. Will that be like a big,
No, half point.
okay.
And probably on the first couple of quizzes, I won't do anything. But by the time we get to the exam, we'll have had a lot of practice on it. Okay.
Is this on the quiz tomorrow?
No.
Okay. Oh, thank you.
Remember, quiz tomorrow was only that fake quiz and the one I sent you.
Thank you.
We're just going ahead with new stuff. We have to keep on track.
Intermediate.
Unfortunately. Yeah,
Right. Yeah.
yeah.
Hey, where
So-
you said those quiz was? Cause I don't have them.
The one is on Canvas. There's a fake quiz on Canvas. I sent you an email. I said it's in the chapter 8 elementary module. And the email also had an attachment with 2 extra problems that we've done.
I put it in the
Okay.
chat just in case.
Okay. And somebody just put it in the chat. Tommy did. Thank you.
How many questions is it?
Oh. I want to say 7, I think. 7. Most of them, the key is, can you factor? That's, they're not all factoring, but that's the key thing for most of that is, can you factor everything? All right, we're going to go on. So everything I've been doing here was, I tried to rush through it last night. It was chapter 8.2. So if you want to go back and put at the top of your notes, this is 8.2. This is simplifying radicals. Okay. I want to show you something on your calculator. Okay. I want to show you something. If you have the TI-36X Pro, okay, other calculators may also do this. It's cool, but it's very limited. Okay, I want you on your calculator to find, there's a square root button and of 8. And then hit enter.
Two square root over 2.
Right. Okay. Those of you with a 36X Pro, could you get it to do that? You have to type in shift or second, what is it?
X to the second power.
Second X to the second power. That's how you get the square root. Then you type in 8, then you type in enter or hit the enter key. Okay, but you get the square root of 8. So wait a minute. The TI-36X Pro will simplify square roots, but it will not simplify cube roots and fourth roots and fifth roots and all those other things. So try this. What's the square root of 18 on your TI-36X?
3 and 2.
So 3 square root of 2. Now, most of you could do that. That's 9 times 2. That's 3 squared times 2. So the 3 comes out like that. You can do that without it. So your TI-36X will do square roots, but it will not do cube roots like this. It will not do fourth roots. So guess what I'm going to have all over the test?
Cube.
Cubes, fourths. I'll have a couple square roots, easy ones. And yeah, if you have the 36X, cool. You get a little, it'll do your work for you. Okay. But I'm going to make sure you know how to simplify. Okay. And you're not using your calculator to do it. You're actually using your brains to do it. So that's why I'm going to force you to use cube roots and fourth roots and fifth roots and all kinds of dumb things, and factor trees and all kinds of stuff. Now, a little bit of theory. Everybody's calculator. Okay. But on the TI-36X, right above the enter key. Is that what I want? Yeah. Above the enter key. So you have enter key, and then you have another key that's got, it's hard to read because for some reason, some idiot put those keys in silver. I don't know, but do you find that one? Okay. What's it do when you push it? If you have this on your screen and you push that little button there. Tell me you get some long, ugly decimal.
2.828427.
Yeah. And it goes on forever and ever and ever. Kind of like pi does. It goes on forever. It's got no pattern. It doesn't repeat, diddly. Okay. We need some discussion. 8 is called an irrational number. Okay. So the square root of 8 is irrational. This is the pretty simplified, exact answer. So if I say I want the exact answer, there it is, 2 root 2, 2 radical 2, 2 times the square root of 2. This is a decimal approximation. Okay, and you must round somehow. That's the reason it's an approximation, is because the decimal goes on forever and ever and ever and ever and ever. Okay, and when your pen runs out of ink and you stop writing, you're approximate. You're by definition approximate. So you need to, I will continue to remind you of this, and this is like the bane of all math teachers. Students don't know what exact means. Exact means don't push the fancy buttons on your calculator. Leave it as 2 radical 2. The minute you move to decimal form by pushing that double arrowhead button there, or whatever it is on your calculator. I know the Casio does a similar thing, but the minute you go to decimal, you're only approximate. Now, what's more useful in engineering? Oh, the decimal. Absolutely. Okay. What's more useful in math, like in trigonometry? The pretty exact form. So we will bounce back and forth. My directions will say, sometimes they'll say, leave your answer exact. That means, okay, leave it as a radical. Sometimes, especially on word problems, it'll say, round your answer to the nearest 10th or to the nearest 100th. Okay, so I wanted to show you 2 things, or 3. Square root of 8, your TI-36 will simplify it for you, but it will only simplify square roots. Okay, and then by pushing the double arrowhead, you get the decimal approximation of these. Okay, and I want to show you that you don't need no stinking calculator. Okay, what if I said, without your calculator, you can make a really good estimate of the square root of 8 without your calculator? Okay, let's see how. Well, we know that the square root of 9 is 3. We know that the square root of 4 is 2. Okay, these we should know from previous classes. Square root of 9 is 3, square root of 4 is 2. So that means the square root of 8 is somewhere between 2 and 3. Somewhere, okay? Who is it closer to? Is it closer to the 3 or is it closer to the 2? Well, 8 is much closer to 9 than it is to 4. So I'm going to say my number is 2 point, I would guess at 8 something or other. That would be my guess without looking here, and I got it. Oh, well, duh, that's stupid. Okay, it was right in front of me. But using your approximation skills, you come really close. So, for example, okay, again, don't cheat. Don't use your calculator. Okay. I want you to find the square root of 52. To the best of your knowledge, I want you to approximate it. Don't simplify it. Give me the approximate value. What is the decimal for the square root of 52? Don't shout it out yet. All right, what two squares is it sandwiched in between? What two numbers?
8 and 7.
Okay, so the square root of 49 is 7, and the square root of 64 is 8. So 52 has to be somewhere between 8 and 7. Okay, who is it closer to?
7.
7 by a little bit. So I'm going to guess 7.1. I want to say 1 or 2. I'm gonna fudge 7.16. I'm going to cheat that way. All right. How close did I get? What's the square root of 52?
Seven point two one one one. Yeah.
Oh,
So
it's
like
a little
7.2.
low. 7. It's what you get on your calculator. Would you say is 7.2111 something? All
Yeah.
right.
Oh,
But
251.
think about that. A little bit of guesswork, a little bit of math, a little bit of guesswork, and I came pretty doggone close. Okay, you guys can do the same. Now, I'm not telling you to use this technique on a test. Use your calculator. Use your calculator. But if you don't have your calculator, or you just kind of want to estimate an answer, you all have the brain power to come close. Okay, there's no magic here. All right, as last night, I would like to go to about 8:45 and quit with no break, get out early. Is that all right with everybody?
Yep.
Anybody gonna yell at me? I don't hear anybody. Okay. All right. So
just to recap,
Yeah.
what would be the answer if it's on a quiz? Yeah, like how would you like the answer? Like,
well, okay, it
Round it up.
depends. It would depend. If I said give the exact value, okay, then of the square root of 52, that would turn out to be 2 square roots of 13. And you'd have to go to your factor tree and whatever. That's the exact value. But if I said give the approximate value, it all depends on the directions. Okay, round to 10th, let's say. I just,
yeah,
one day I may say round to the 10th. The next day I may say round to the 100th. But everything depends on the directions. So if I say give me the exact, then you do all that junk that we all erased, get powers of 2 or use your calculator because this is a square root.
Mhm.
Okay.
Mhm.
So what did I get for
2 over 13. Well, yeah, it will be 7.2111.
Yeah, we just did that. That
Yeah.
was pretty stupid of me. 7.211, whatever it was. So that rounds to 7.2
Gotcha.
because it said round. So again, it all depends on what were the directions. Exact, approximate.
Understood.
Okay. Anybody else? Okay, then oh, there it is. Okay. We're gonna jump to where's my notes? I had these organized this morning and now I've lost them. Oh, there we go. We're going to jump to section 8.4. Chapter 8.4. We want to talk about multiply, add, subtract, radicals. Okay, let's concentrate on multiply. I use something that I call the inside, outside rule. Takes more time to write it than it does to say it. Okay, then simplify if possible. So inside, outside. Sounds like Foster's playing with his belly button again. Inside, outside, and we are multiplying. It's easier just to give you an example. 8 times the cube root. No, we'll stick with square root. 8 times the square root of 6x times 5 times the square root of 2x. Okay, what do you think? Okay, we are multiplying. We're multiplying because it's this 8 times the square root of 6x times this. Okay, what do you think inside, outside could possibly mean?
8 times 5 and 6x.
Bingo, it's that simple. 8 times 5 is 40. Inside is 12x to the second. Okay, we're not done, but that's an excellent start. So outside, 8 times 5 is 40. Inside, 6 times 2 is 12. X times x is x squared. Is that okay with everybody? Again, we're not done, but that's a key step right there. All right. Then why aren't we done?
Simplify.
Yeah, we got to simplify. And this is where we come back. Okay, the 40 is hanging around here. We look at 12 and go off to my scratch paper. 12 is 4 times 3, which is 2 squared times 3. So I have 2 squared times 3 times x squared. Remember, we just did that about a half an hour ago. So who comes out?
40, or sorry, 2 and x.
The 2 and the x. So there's a 40 that's already out there, times a 2, times an x, they come out, and the 3 stays inside. So what's 40 times 2? 80 x times the square root of 3. That's the answer. So let's look at this. Right where I'm drawing this line, that's where we did the multiplying rule. We did the outside, outside, inside, inside. Bingo. The rest of this was simplifying like we did in the first part of this class. How do you simplify a radical? You use your factor tree. You remember that the index on this one is a 2, so you had to get it in groups of 2. Okay, that's the answer. Multiplying is really, really kind of nice. Let's take another problem. Let's take -2 times the cube root of 4x squared y squared times 3 times the cube root of, let's go 2x y to the 5th. So go ahead, multiply those together and simplify if possible. Okay, I don't hear anybody yelling now that we're recording. All right, so we need to now break all these down into groups of 3 because of the index. So go off to my scratch paper, and if you want me to show you, I'm going to put the answers here for now, but 8 becomes 2 to the 3rd. X is, yay, x to the 3rd. Y to the 7th is y to the 3rd times y to the 3rd times y. So a 2 comes out, an x comes out, and 2 y's come out. So I have -6, or I'm in the glare. Okay, but -6 is already out there times a 2 that I bring out, an x that I bring out, and 2 y's that I bring out. And who's inside? Just the y. So put it all together. Oh, you can't see it. -12 x y to the 2nd, -12 x y to the 2nd times the cube root of y. And that would be my final simplified answer. Yes or no?
Yes.
Good. Okay. Now, there are some videos on my YouTube. I think there's some videos that are posted with Mom. Different people do this slightly differently. Okay. Can you put 2 adverbs next to each other? Is that good English? Slightly differently. I'm not sure that's right. Well, whatever. They do it differently than I do. A little bit. Okay. If you like their way or somebody shows you a slightly different way, that's cool. I really don't care the steps you go through to get to this answer, as long as you get to this answer, because there's a lot of room for variation. There's a lot. And so you may find a shortcut as you're working these problems out, going, why didn't Foster show me this? Well, great. If it works, use it. All right. I'm going to come back to multiply, but now I want to go into add and subtract. Okay. And then in a few minutes before we leave, then I'm going to combine multiply with add and subtract. So they're all going to get lumped together in one big, giant, ugly mess. So I need to erase the board. Somewhere in your notes, highlight that to multiply, okay, we use the outside, outside, inside, inside rule, and then we try to simplify if possible. That's a key. Okay, All right. Now we're still in the same section, chapter 8.4. We want to add and subtract. And the first key is must have same index. Okay, that's number one. If they don't have the same index, if I, for example, say, what's 5 times the cube root of 2 plus, 3 times the 4th root of 7, you can't add those. That's a cube root, that's a 4th root, that's a 2, that's a 7. You can't do nothing. This is dead. Okay, so they got to at least have the same index. Okay, and okay, think like terms. Okay, so let's do a quickie review. Suppose you had 2 x plus 3y minus 5x plus 2y. Okay, now we keep getting all kinds of numbers, weird answers. What's the answer to this problem? If I told you to simplify this, what's the answer to this?
Negative 3x 5y plus 5y
Plus or minus
plus 5y.
plus 5y. I agree completely. Does anybody not agree with that or not understand it? Okay. The rule was way back in chapter 1 and 2, when you're adding or subtracting like terms, you add their coefficient, add or subtract the coefficient, and you keep their variable. You add or subtract the coefficient, keep the variable. So 2 take away 5 is 3, keep negative 3 rather, keep the x. 3 plus 2 is 5, keep the y. That was the rule for like terms. Okay, hold on to your shorts. 2 radical 7 plus 3 radical 6 minus 5 radical 7 plus 2 radical 6. Okay, in my mind, I see absolutely no difference between this problem and this problem. None whatsoever. Add like terms. So who are the like terms up here in this new problem I just wrote?
The radical 6 and radical 7.
Okay, so 2 radical 7, 5 radical 7. What do they become?
Negative 3 over 7.
Over?
I'm sorry, negative 3 radical 7.
Yeah. Add the coefficients, keep the radical, keep the like term. Same as this. Okay. What about anybody 3 radical 6 and 2 radical 6? What would that make?
5 radical
5
6. Yeah.
plus a 5 radical 6. That's the answer. So when you have an opportunity to go back and review your notes, every time we're adding, we're thinking like terms. This problem and this problem are 99% identical to each other. The same rules apply. You can only add, if I want to add with a radical 7, I can only add with radical 7s. But what do I actually add? The coefficient, the number in front. All right. Well, here's the problem. It just can't be that easy. You know, math. We introduce something and you go, I've got it. This is really easy. And then all of a sudden we go, ha, 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 tricked you. No, it's not. Okay. So I need to erase this and show you. I don't want to call it a trick, but how it gets a little messy. Okay. Can I erase these two examples? Yes, no, maybe so.
Yeah.
All right. All right. So here we go. Example. Square root of 12 plus the 3 times the square root of 27. There's a good one. Okay. Can you add them right now? Can you add them?
No,
Okay. Because they're not like terms. That's the square root of 12. That's the square root of 27. Can you simplify them?
Yes.
Do it. Can't add. Can simplify. Now, by the way, these are square roots. So those of you who have the TI 36, you know, if you want the practice, I think you should do it by hand. But if you got it, the 36, I can't take that button away from you.
2 radical 3 plus 9 radical 3.
Okay. I agree. Square root of 12, I guess I'm going to put in an extra. This becomes 2 squared times 3. If you break down 12, so it becomes 2 radical 3. Remember, these are square roots, so we're looking for groups of 2 or powers of 2. 12 breaks down to that. The 2 comes out. Okay. 27, this is 3 times. Okay. 27 is 3 squared times 3. So this 3 comes out. So I have a 3 times a 3 that comes out, and this 3 stays inside. So I have 2 radical 3 plus 9 radical 3. Okay, I've simplified. Am I done?
no,
No, because I can add by simplifying, okay, all the way down, I have like terms now. By simplifying, I have like terms, and my computer's telling me I'm going to die. Wait a minute, excuse me. Please don't die, computer. I believe, don't die, don't die. You guys follow what happened? Originally, we couldn't add, but we could simplify. So we simplified. And all of a sudden, through our simplifying methods, okay, we get down here and they are like terms. So my final answer is 11 radical 3. Because the rule was for adding like radicals, you add the coefficient, keep the radical. Add the coefficient, keep the radical. Yes or no? I get those of you with the TI 36. Can you type that in as it is and then press the enter?
Yeah, it comes out to 9 radical 3 right
So
away.
it does understand the 3 in front.
Correct.
Cool. Okay, that's a feature I didn't even think it had. That's pretty neat. All right. Try this one. New problem. Square root of 32 m to the 7th minus square root of 50 m to the 7th. I apologize. I put this problem up here, and to show you all my steps, I don't have enough room. So I'll show you the key steps, and then if you need to see how I got these, I'll do those for you off to the side. But 32 m to the 7th can simplify. Now, you can use your calculator to break down 32. That was 4 radical 2. So your calculator will do that part for you, the 4 radical 2. Same thing with, you can use your calculator, the square root of 50 will break down into 5 radical 2. Okay, so your calculator can help you a little bit. The m to the 7th, you break it down to a bunch of m to the 2nd powers. Remember, the index on here was a 2 and a 2. Okay. So anyway, this simplifies into this mess, 4m cubed. This simplifies into this set. Can I subtract them? And the rule is, yeah, you can, because the radicals are the same. This and this are the same. So technically, we want to do 4m to the 3rd minus 5m to the 3rd times the square root of 2m. Now, you don't have to put this step down, but you sure as heck have to think it. So what's 4m to the 3rd? Take away 5m to the 3rd. Anybody?
-1.
Negative
-1
1
cube.
m to the 3rd, or m cubed, times this mess. Square root of 2m, whatever it is. Yes or no? And does anybody need more steps?
Good.
Why is
Okay.
it m to the 3rd?
Okay. You mean here?
Yeah.
At that step? Okay. Because,
It needs a lot of paper.
yeah, I do. I need a lot of paper. Okay. Let's take the 32m to the 7. Square root of 32m to the 7. Okay. That's the square root of 2 squared times 2 squared times 2 times m to the 2nd times m to the 2nd times m to the 2nd times m. Okay. Remember, you want to break the 7 into groups of 2. M squared, m squared, m squared. There's 6 of them and one more. So when things come outside, okay, who comes outside? All the powers of 2. So this 2 comes out, this 2 comes out, this m comes out, this m comes out, this m comes out, and who's on the inside? This 2 and this other m over here. So put it all together, we have 4m to the 3rd on the outside, and still left m inside is 2m inside the radical. Now, did I go too fast, or does that answer the question?
That answers.
Okay. Anybody else? And something similar happens for over here. It's the same idea. Yes or no? Okay. Then That's just add and subtract. Now I want to put all of this together. I want to multiply and add and subtract and ruin your life. Okay, how can I do that? Well, first example is, what if you had 3 times the square root of 2 times 5 times the square root of 2 plus the square root of 3? What if I had something like that? Well, what's the problem asking me to do? In basic algebra language, what is it asking me to do?
Parentheses first.
Well, but you can't add these. You want to, but you can't because they're not like terms. So what's distributive? That's what I was looking for. This is being asked to multiply to here and to here. It's a distributive property. So this problem is 3 radical 2 times 5 radical 2 plus 3 radical 2 times radical 3. Now, remember, I'm saying radical. I could just as easily be saying square root. Radical, square root, synonymous in this case. Okay, so that's the first thing I see here is I'm going to distribute. Okay, now I see multiplication. Multiplication is going to use the inside, outside rule. Because now this is multiplying. And so is this. This is multiplying. So I'm going to use inside, outside rule. So over here, outside, 3 times 5, that's 15. Radical, inside is 4. Now here, this gives people trouble. Look where I'm pointing. Look at this radical 3. What's the coefficient of radical 3? What's the number in front of radical 3?
Uno.
Uno, thank you. I win. Okay, where's my pen? 1 is here. Uno. So when you use outside, you're really doing 3 times 1 is 3. Inside is radical 6. Okay. Now you look at that and you go, okay, am I done? Are you done? That's the question. Are you done? Can you simplify any radical? Can you break down the square root of 6 anymore?
Yes.
Okay, into what?
2 and 3.
But do they come out?
No, they don't.
They don't come out. That's the key. Yes, you could break it down, but remember, because it's a square root, they have to have a square power to come out. So yeah, but didn't do me any good. Okay, what about 4? Square root of 4.
Yes.
Okay, so you don't even have to, if you know that the square root of 4 is 2, just use it. It's 2. You don't have to go through all this fancy math crap. It's just 2. So this is 30 plus 3 radical 6. And we're done. That's it. Those are not like terms. So I can't add them. So I quit. So notice how we use the distributive property to get the 3 radical 2 times each one. Then we use the multiplication property, inside, outside, to do multiplication. And we simplify. Isn't it fun? Okay, I hear vomiting in the background.
So I can see some people, they try to, I guess, follow the inside outside rule with the radical 4 against radical 6, like because it's multiplication, but since it's not like terms,
Right,
Yeah, okay.
right.
I just wanted to clarify.
Exactly. No, that's good call. And further, the score to 4, that should be after a weekend of study, that should be automatic. You guys, you should know like score to 4 is 2, score to 9 is 3, score to 16 is 4. You should know your square roots up to the square root of 100 at least, because they just keep showing up all the time. Square root of 1 is 1. So, but again, after some practice, after doing this, so instead of having to break that down and follow all the silly steps, you go, well, duh, the square root of 4 is 2, and I'm not going to do any work. I'm just going to say it's 2. So you should be developing some skills on some of these to help you save steps. All right. Anybody remember? We're running out of time. I want to do 2 radical 3 plus 4 times 2 radical 3 minus 1. Okay. If you recall, there's several ways to do this. Many of you decided you liked the matrix method. So I'm going to go 2 radical 3 and 4 and 2 radical 3 and negative 1. When we multiplied the 2 binomials, okay, one of the techniques was the matrix method. I've seen your guys work. Some of you use a process called FOIL, which is fine. Okay, I don't care, but we all have to get the same answer. So set up a matrix. We're going to go 2 radical 3 times 2 radical 3 is we're using, because we're multiplying, we're using inside, inside, outside, outside. So that's going to become 4 radical 9. Then 2 radical 3 times 1 is negative 2 radical 3. Negative 2 radical 3 times negative 1 is that. 4 times that is 8 radical 3. 4 times 2 radical 3 is 8 radical 3. And 4 times negative 1 is negative 4. Okay. So let's look what I have here. I'm going to write this out so we can see it. I have 4 radical 9 minus 2 radical 3 minus 8 radical 3 minus 4. Anybody see anything I can do?
The 3s. So it'd be 4 radical 9 minus 10. Would that be a negative 10 or minus 10?
Minus 10, minus 10, negative 10, same thing.
Yeah, radical 3 minus 4. Yeah.
Okay. You got half of it, which is pretty good. What's the square root of 9 worth?
3.
3. So this is 4 times 3. So this is 12. Okay. And you correctly said this is minus 10 radical 3 minus 4. Okay.
So then you
Well,
can break that down even more, huh? To where
bingo. So what do you
8.
get for a final answer?
So the 8 minus 10 radical 3.
Bingo. That's it. 8 minus 10 radical 3. So back up here, when we had to multiply binomials times binomials, you guys like the matrix method, but the matrix method, because we're multiplying radicals, we're using the inside, inside, outside, outside rule. That's for multiplying radicals. Okay. I rewrote all my insides in here, all this mess, so we could see it more clearly. Square root of 9, that was one of those ones you guys need to know instantly. 4 times 3 was 12. These correctly were seen as like terms. So you add -2 and 8 is -10, keep the radical 3, and you're done. And I promised to get us out of here at 45. It's 45. Hasta bye-bye tomorrow night on campus. Okay,
All right,
if
good
I
night.
Adios.
if I have to crawl, tomorrow night is on campus. See you.
Instructor,
Yes, sir.
how did the +8 turn into -8 again? Sorry.
Yeah, I have same question. It should be plus.
It should be
plus
+8, right? Plus
Yeah.
8 radical 3. That's what I thought.
Oh, crap.
Yeah.
You're right. I'm wrong. So it's 6. You're right. And everybody's left. Okay. Fortunately, I'm still recording, so everybody in the world.
Yeah, I didn't
is
want to
gonna-
interrupt you. I was like,
No,
whoa,
you
it's-
should have.
yeah,
Those are the things.
yeah,
Interrupt me.
Yeah.
But that's what I want you to do. You know, when have I ever made fun of anybody? Really? Oh, never mind. Okay. Yeah, you're right. That should have been plus. So this should have been +6.
Yep.
Radical 3. Yeah, you guys yell at me. Come on. Interrupt. That makes me feel actually better. It means you guys are paying attention.
Yeah.
I like that. Okay. All right. Thank you. So I need to go back over that tomorrow in class. Damn it. Damn it. Damn it. Damn it. All right. Other questions? Anybody who's still here?
No, they should be it. Thank you.
Okay. All right. See you guys
Have
all
a good
tomorrow.
night.
Night night. Oops. Let's stop recording.